Okay, Bismillahirrahmanirrahim. So now we're going to formally learn how to graph these, okay? This knowledge also takes time to sink in. So if you don't get everything the first time, just be patient, inshallah. So you kind of have to know, you kind of have to memorize the y equals sine x graph, and you have to like memorize y equals cosine x graph. Now, you have to be careful how you see x and y's, right? In this case, x is the measure of angles, and it's not in degrees, but it's in radians. You follow? Assalamu alaikum. Bismillahirrahmanirrahim. Okay, now look. So you kind of have to like memorize the graphs. In other words, it's kind of like the parent function, right? Okay, so you kind of have to know the parent function. So you do kind of, the first thing to know is that the basic appearance of y equals sine of x and y equals cosine of x, okay? Y equals sine of x looks like this, right? Like this, right? And y equals cosine of x, cosine, looks like this. You follow? Obviously, I didn't do a very good job here. You get the idea, right? It's the artistic representation with liberties. All right, that's sweet. Now listen. That's the first thing. So if you want to, so if somebody start, okay, they're trying to, how do I start a sine curve? Okay, let's make some on one of these tables. That ain't gonna work. You know, that's gonna be very tough. But you have to know what the parent function looks like, and then you're gonna like after you're done with everything else, you just move it around this and that, right? Okay. So let's start off with the sine curve. Okay. Now and then we said, you are going to have domain and range. What's the range of the sine curve? 1 to -1, right? They all go from, let's say, just make that 1, and this is -1. So we could just kind of theoretically, yeah, we could just make like, this is like going to be the roof of the range, right? Kind of like this. It's not going to go higher than that, right? And it's not going to go lower than this, right? Correct? And then it's going to go one of these numbers over here, right? Okay. Now, okay, sorry here. Okay, okay, start again. So first we're going to graph y equals sine of x, okay? Okay, so now this function is going to go from 1 to -1, we established that. So the range is going to be this. It's going to be kind of capped at this. Now you don't have to draw this line when you draw this, okay? I'm just doing this so you can appreciate it more. Now, and then the graph is going to do one of these numbers, as I said, okay? Now it's going to go from 0 to 2 pi, that's 360 degrees, okay? And then this is how I do this. Okay, I know my graph is going to be in this kind of like square over here, from 0 to 2 pi, right? Do you understand that? Okay. So I know that. So I know that if I draw from here to here, I've done it. The rest of it I can just copy paste. You follow what I'm saying? And then what I do is, okay, I divide that into half. Okay, that's pi over here. So that's 2 pi, that's pi, right? Because, and then I know it's gonna y equals sine of x. The parent graph looks like this, right? So half of it looks like that, and half of it's gonna look like this. Do you follow? Okay, so this is my first half, so that's going to have to take one of the, like, you know, the mountains, like this, and have to come back over here by this time, right? And then it's going to have to go over here, and it's going to, the lowest point is going to be over here, right? And then it has to come back over here. That's it. That's how you graph this function, okay? And then, well, then, okay, you want it looks kind of like empty, right? So, okay, well, fine, I can handle this. I'll go to -2 pi, and that's the half of it. You know, okay, this half is going to have half of this curve is going to go, okay, it's going to have to go like this, right? and then it's going to go like, going to climax over there. And okay, fine, I could do that. It's not a big deal. If you want to, I could do more of it. Do you understand? Okay, so that's the graph of the parent function. Okay, and then we talked about some of this. Okay, from here to here, from this to this. Okay, that's called the period of the graph. Okay, and from here to here, like here, that's the amplitude of the graph. Okay, the period of the graph, okay, is determined by actually this in here, because these are going to get complicated, right? It's not going to be just the same x. We're aiming for this. Y is going to be like a times sine of x minus vx plus vy. Okay, in the most complicated of this, there's going to be a coefficient in front of the x over there, and you can call that b if you want to. Okay, but the period is going to depend on this. The amplitude is going to depend on this, what's in front of the sine. Okay, so we're going to take it slow. Got it? Okay. So now, but this is very similar to all the functions in this book. It's amazing. That's why when I said this to the other kids over there, they said, that's it? That's it? Because every single type of function that we studied in the whole book, from chapter 1 all the way up to chapter 10, they had the same pattern. Same pattern as what? As initial the quadratic functions, which is x minus vx squared plus vy. They all look like this. Look, this, and this defining feature, this, and this. You see? They all look the same. I mean, it's amazing how if you understand, all starts with chapter 1 stuff. So we're going to build on this. Okay? So we graphed y equals sine of x. Okay? Now if I graph y equals 2 sine of x, okay, now what's going to change is this, the period, okay? So instead of being 1, the roof is going to be at 2. The period is going to be from 2 to 2. Now you're going to stretch the graph like this, right?
So it's not the unit circle anymore?
No, it's not. So if somebody says, can the sine of any angle, can the sine ever be greater than 1? Can the sine of it ever? No. But if a function can be, you understand what I'm saying? You're not graphing sine, you're graphing 2 times the sine of something. Do you understand? Okay. So unit circle is the reference for all these things. Yes, sir.
So if you do 2 sine, then it just goes up 1.
Yes, the amplitude changes. What's the amplitude of this graph?
It's kind of like the y-intercept. 0.
The amplitude is the height, the maximum height.
Oh, 1.
This one, right here.
But that's 2.
That's going to be 2. So it's going to go to 2. So this graph, and the period is going to remain the same, okay? So this graph is going to be like this. Yes?
So the
Go ahead.
amplitude will only be from the x-axis up, right? It won't be like what's beneath it.
Yeah, it's like, what's beneath it is kind of like a reflection. Yeah?
So you won't count that.
No. The amplitude is from this height. Right? It's how tall is the building? From where? From the all the way in the ground, you know, where they dug up the ground? No. It's like that. You understand? It's the height of it. Okay? So that's the amplitude. Okay, now watch this.
Like half line right before you get under the side. You can write that same thing as a
The
quadratic equation, right? You need half sine and all that, right? Because it looks exactly like a parabola.
No, it's not. Oh, it's definitely not a quadratic function. Yeah. It's so for some function to be quadratic, they have certain behavior. Do you understand? So, for example, the arch of St. Louis, okay, St. Louis arch, okay, it's like a parabolic function. If it was not a parabolic function, it would not be as stable. In other words, if the properties of the graph were to change, the whole structure could potentially be vulnerable. So a parabola, for example, is not the same as hyperbola. Hyperbola has asymptotes, parabola has no asymptotes. Do you understand what I'm saying? So they look similar, yeah? A U looks like a V, but a Victor is not a Victor. You understand what I mean? They're very different problems. Their properties, they are very different. So they're not the same. Same thing here. Okay. Now, are you so far you understand this? Okay, so I'm going to give you guys like an exercise right here, okay? Oopsie daisy. Okay, you guys are going to do this, okay? Ready? You guys are going to graph this on your own graph sheet, okay? On your piece of paper. So you are going to graph, you're going to label x-axis from pi to pi and all of that stuff. You're going to do everything I did, and you're going to graph y equals 3 sine of x, okay? Inshallah, go for it. Okay, so this one, y equals 2 cosine. First of all, you kind of have to know what y equals cosine of x looks like, okay? That's the parent function. So y equals cosine of x, okay? It's, you just kind of have to, like, you know, it makes it easy if you know it's the cozy cosine, right? It's like that. So, so the period for the parent function is going to be this. That's the half of this, and the amplitude is 1, right? It's going to be like this, okay? And then you just graph it in. But the cosine is going to go, and it's going to go to this point over here, and it's going to be like here, and like this. So that's the parent function. Do you understand? Does that make sense to everybody? Okay? Now, this one is 2 times of that. That means the amplitude is going to be changed. 2 and negative 2 over here. So it's going to start off like this, but the half of the graph will still be here. The period is still the same. It's going to be 2 pi. So it's going to be kind of like constrained in these 4 boxes. You understand this? Half of this, right? So, and still going to start up like that, like a hammock over there. And still going to go to this point right there. But it's going to go all the way over here. And it's going to make a turn here. And it's still going to go to this point over here. And it's going to go over there. You see? So let me draw this here on our graph paper. So here's y equals cosine of x. Okay? You see this? And then this is y equals 2 cosine of x. Do you see this? It's still going to go through those 2 points. See, pi over 2, pi, 3 pi over 2, 2 pi. Does that make sense? Now, look what happens if I do this. Y equals negative 2 cosine of x. See? It's the cosine, this graph flipped. Yeah? So it's this graph, it's going to start here, but then the halfway points are still going to be the same, see? That's the key. So the thing is to rectangulate it, so to speak, right? Corner it. And then the last thing you do is connect all the dots. Does that make sense? Okay. So that's that. Okay. This is where we're going, okay? This is like going to be a climax of our graph, okay? This is not what we're going to do next, but I'm just telling you. Minus 3 sine of 2 times x minus pi over 2 plus 4. Now, if you can graph this, you can graph any sine function, okay? That's where we're going. So we're going to add some elements to it slowly. So we added this, okay? Now, what we're going to I'm going to add this first, okay? And then we're going to add this over here. And that's the last thing we're going to add over here, okay? So, now, I want you to graph this one, okay? Y equals 2 sine of x. But you just did that, right? Plus 3. No, you didn't. Okay? What's going to happen? Move the whole graph up 3 units, right? Do you understand? plus the amplitude is going to be 2, right? The period is not going to change. It's still going to be 2 pi. The period is not going to change. All you're going to do is you're going to take this graph and move it up by 3 units. Correct?
Oh, okay.
Yeah?
It starts at
Well, that's the tricky thing. So if y equals sine of x is going to look like this, right? Well, like this, right? So this graph is going to, this point right here is going to be 1, 2, 3 over here. And then the amplitude is 2, so it's going to be like this. You follow? And then you're going to make this box over here, and this box is going to be here. You follow like this. Do you understand? And then you just put this over here. Like that. Do you understand that? Okay. So let's do it.
Sorry.
No worries, Isha.
From the HD microphone.